We are in grade 11 mathematics, and we are going to look at arc length and sector area. This subtopic is under the main topic mensuration. Mensuration, right? Mensuration. Okay, so this is the topic, this one, but this is a subtopic. All right, now arc length and sector area. Let's review the arc and the sector. Um, if we have a circle, all right, I'm sorry, if we have a circle and this is the center of our circle, okay, what happens is that we 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 can talk of this part, this this length here as the circumference. So the distance around a circle is called a circumference. Circumference is the distance around the circle. So the formula for the circumference, which is c, equals to pi multiplied by diameter. Or sometimes this can be equal to pi 2 pi radius. Why? Because diameter is equal to 2 radii. Okay? When you multiply radius by 2, you get diameter. So if we substitute, instead of the diameter here, we put 2r, then we have this. This is the formula for the circumference of a circle. But when we talk of the arc now is a fraction. This arc is a fraction of the circumference. It's a fraction of circumference. That means it's just part of a circumference. Okay? All right. So arc is a fraction of the circumference. Circumference is the complete journey around a circle. If you go around a circle and you complete the circle, then you have walked the circumference of that circle. Okay. But if you say you start from here, point A, you go and then you come to point B here. This is just a fraction of the circumference. From here to here is not a complete circle. So it's just a fraction of that circumference. So this is what we call the arc. Okay? So now the arc length now would be different from the circumference. They won't be the same. There should be the fraction, and that fraction is taken from the angle here. This angle here. Let's call it angle theta. Okay? So it depends on what is the value of this angle over 360, because if you go around a complete circle, if you rotate around a complete circle, then you have rotated 360 degrees. That is the revolutionary angle. All right. Now, a fraction of that angle then would be that angle theta over 360 degrees. Okay. This fraction, now, if we want to find the arc length, we will say is the fraction of the circumference. Of means multiplication. So, is this fraction multiplied by the circumference? Okay, that would be the arc length. This is the arc length. Okay, now the arc length is a fraction of the circumference. But now, the circumference the circumference is actually pi diameter. So that means we ultimately have theta, the angle, times pi diameter. Okay, this would be the arc length. This becomes the arc length. Okay, This becomes the arc length. If you want to find the length of this arc, then you would just say the theta over 360 degrees times pi times diameter of the circle. Okay? Now, let's say you wanted to find this side here, this arc length. Remember, this is the major arc and this is the minor arc. Now, the minor arc length would be this one. The major arc length would be this one. So what is this angle here? This angle here, if this angle is theta, the angle here is going to be 360 degrees minus theta. So now, if you want to find the arc length of the major arc, this one, from here to here, that means you are going to say, okay, is the fraction of the angle, which is 360 minus theta, all over 360 degrees times pi diameter. This would give you the length of this major arc. So you just need to know this angle. If you know this one, you can subtract it from 360 to get this one. Then you put that value here over 360. It's the fraction of the circumference. So that is the arc length. Okay. Now let's have an example. Let's have an example here. I will show you how this is can be very important. I will show you how it can be important. Let's say we have a circle. Let's say we have a circle and there is the center and it's 40 degrees here. Okay? And then they want you to find the measure arc length. Measure arc length. What does that mean? Measure arc length is this one from here to here. That is the measure arc length from here to here. This. So that means you will have to find this angle here. So that would be 360 minus 40, which is 320. Okay? So you would say arc length equals to theta over 360 degrees times pi diameter. So let's say the radius here is 7 centimeters. Okay? Now, if you substitute here, you are going to have this angle, which is 320 degrees over 360 degrees times pi times diameter. So if the radius is 7 centimeters, then diameter would be 14 centimeters because diameter is 2 radii. Okay? Now, this is what you are going to work with. This is what you will be working with. All right? So work out this. What do you find? What do you get? What do you get there? Hmm? What do you get? All right. Okay, I hope you have got 39 centimeters. I hope you have got 39 centimeters as the length of this measure arc here. What if that means it's the measure arc length? Let's say measure, okay, measure arc length. What about the minor arc length? Minor arc length. The minor arc length. The minor arc length would be this one, this arc here, from here to here, this one. Okay, it's the minor arc. So the minor arc length would still be theta over 360 degrees times pi diameter. But in this case, theta is 40 degrees over 360 degrees. Is this angle, which corresponds to the arc here, multiplied by 3.142 times diameter, which is 14 centimeters. Okay, that is this. So what do you get? Can you work this out and tell me what you get? Now, you will work it out. 40 multiplied by 3.142 multiply that by 14, right? And divide this by 360. I get 5 centimeters. Okay, so it depends on which arc you are being asked to find its length. So if it's the major arc, you will use the corresponding angle, the angle which corresponds, which is this reflex angle, which corresponds to the major arc. If it's the minor arc, you use this acute angle, which corresponds to the minor arc. Yeah, now let's continue and look at how you deal with the area. Let's look at a circle. Our circle could be this circle, and this is the center. Now, remember, when you talk of a sector, we are talking about this region, the whole region here, between the arc and the two radii. This is the sector. Okay, so this is the minor sector. We did this topic. We talked about this circle properties. This is the minor sector. I'm just reviewing it. Okay, and then this is the major sector. Okay, now we are talking about the sector area here. That means we are not talking about length but area. So since a sector, look at the sector. What is a sector? A sector is actually a fraction. It's a fraction of the circle. Fraction of circle. A circle. Fraction of a circle. Okay? It's a fraction of a circle. So if you are asked to find the area of a sector, you are actually being asked to find the fraction of the area of a circle. So what is the area of a circle? Area of a circle is equal to pi radius squared. Okay, so if you are going to find the sector area now, it means you are actually trying to find a fraction, and this fraction is always theta over 360 degrees. A fraction of is multiplication of the area of a circle, which is pi r squared. Okay, this is the sector area. It's a fraction of the area of a circle, since a sector is the fraction of a circle. Okay, now uh, uh, theta would be the angle here. Theta would be this angle if you are looking at the shaded area, which is the minor sector. But if you are looking at the unshaded area, then your theta would be this angle here, which is 360 minus this. Okay? Okay? Now, let's take for instance. Now, let's say you have a circle, and you are told that, okay, Let's say this is 120 degrees, and this is the sector now. Find the area of the shaded region. The shaded region here is the minor sector. It's this one. The shaded region here is the minor sector. Okay, this one. So area of a sector, it's let's say the radius here. It's let me just say 8 centimeters. Now, what happens is this. You know that sector area equals to you will say sector area equals to theta over 360 degrees times pi r squared. All right. Now, here it's obvious that our theta is 120 degrees. We'll say over 360 degrees from the formula. Then we multiply this by 3.142, which is the pi. Then we multiply this by 8 centimeters squared. Okay, so what do you get? What do you get? 8 centimeters squared is 64. Okay, so that says you will multiply 120 by 3.142 and multiply that by 64 centimeters squared. Then you will get a value and divide that value by 360. You get 67 centimeters squared. That's the area of this sector here. The area of this sector. So what if you were asked to find the area of this sector, this one, the major sector? That means you would just find the theta here, which is 360 minus 120, which is 240 degrees. Now you are going to have 240 degrees over 360 degrees multiplied by pi r squared. It's the same. The difference is the theta here. Then you would work this out. Okay? What would you get? 240 multiplied by 3.142 multiplied by 64 divided by 360. Continue. You say 240 multiply by 3.142 multiplied by 64, right? Then divide that by 360. Get 134, okay? That gives you 134. 134 centimeters squared, okay? 134 centimeters squared. So in a nutshell, that's how we find we calculate the arc length as well as the sector area. Until we meet again next time.